Others and multiplexers, the building blocks of digital logic, foundational components in all digital electronics, enabling complex computations and data management, critical for CPUs, networking, and embedded systems. In this presentation, we'll be talking about adders and multiplexers. So I'll define what adders are and give some applications of adders and do the same for multiplexers. So adders, the core of digital arithmetic. Digital circuits engineered to perform binary addition. They are the essential arithmetic logic units within CPUs. Modern processors rely on adders to handle complex 64-bit calculation, executing millions of additions per second. In other words, adders are digital circuits that perform arithmetic addition. Fundamental of ALUs, which is the arithmetic logic unit, the heart of the CPU arithmetic operation. High-speed calculations process millions of operations per second. These are some of the uses of adders. Adder, adder types and logic. So we have four types of adders. The half adder. Half adder adds two single bits, generating a sum and a carry out. The full adder talks about adding three single bits into brackets, two inputs, one carry in, producing a sum and carry out. The ripple carry adder chains full adders for multi-bit sums, propagating carrying sequentially. Advanced adders. Modern CPU utilizes techniques like carry look ahead for enhanced speed. So these are some of the types of adders. So now we move on to multiplexers. Multiplexers. Multiplexers are often called MUX, are crucial digital components that select one of n input data lines and direct it to a single output line. This selection is controlled by a set of select lines, where 2 raised to the power n input corresponds to an n select lines. They are indispensable for efficient data routing and signal consolidation in digital electronics. So some uses of adders. How the adders work, it's controlled by select lines. So the select line determines which input passes through the multiplexer. The data routing and consolidation streamline complex data pathways. Types of multiplexers and logic. So we have the 2-1 MUX. Selects between data inputs using one select line for one output. And we also have the 4-to-1 MUX. Handles four data inputs within two select lines, feeding to a single output. 8-to-1 MUX is also a type of multiplexer which manages 8 data inputs with 3 select lines for 8 single outputs. Boolean logic implementation can directly generate a complex Boolean function with n variables. So this part of the slides will be discussing about the applications of both the adders and multiplexers. So application of adders for central processing units. From the main components of arithmetic logic units. Graphics processing unit, that's the GPUs, performs millions of parallel additions for complex rendering tasks. 3. Digital signal processors, DSPs, essential for real-time audio and video processing, enabling filters and effects. Embedded systems used in control systems, calculators, and various measurement devices. So these are some applications of others. Yeah, and it's also used in cryptography. Yeah, cryptography is also cryptography is also a way of cryptography is one of the practice and study of techniques for secure communication by transforming plain text into unreadable chip text. Yeah. So now I move on to applications of multiplexers. Data routing. Data routing. Ah, Data routing, directing high-speed data traffic in networks like 100 Gbps, intranet switches. That's one use of the multiplexers. It's also used for memory addressing, selecting specific memory locations for crucial RAM addresses, decoders, communication systems, multiplexing multiple signals over a single channel for efficient transmission, and logic function generation, capable of implementing any Boolean function, directly simplifying circuit design. Multiplexers can also be classified based on their functionality, such as digital multiplexers and analog multiplexers. So for the digital multiplexers, handles digital signal, and the analog multiplexer also handles analog signals. So in conclusion, we are also talking about the essential for modern technology. Others and multiplexers are fundamental digital building blocks that enable the speed and complexity for current computing found in nearly every electronic device con- we use continuously. Innovation in these areas drives performance and efficiency towards work. This brings me to the end of my presentation.